really close that you guys can start checking. Here we go. I know the answers look so easy, and yet the work was so much more involved, right? But let's go ahead and check the answers and get down what we can as far as the right or wrong, the locals, the local mins, the local maxes, the relative. Oh, relative is local, right? The absolute extrema, the relative extrema. PS in number 8, just because EVT doesn't apply doesn't mean there can't be a max or min. There just happened to also not be a max or min based on the behavior of the function. I do want to hear your questions. I do have the book up and ready to go, but we'll get answers first. Can I scroll down a little bit? I like some of the explanations, not that you guys need to write them all down, but I like some of the explanations as far as, hey, there's a critical number, there are no endpoints, any extrema must only occur at the critical number then, etc. Why on earth, on 14, would they be considering limits to infinity? What's a limit doing in the problem? Kind of. The domain, I think the domain is all real numbers, right? But why take a limit? What's the point? Yeah, it has to do with behavior, right? Sign charts will just tell you increasing, decreasing, but will it tell you how much decreasing or how much increasing? Horizontal asymptotes, on the other hand, might help. So if we could think about horizontal asymptotes, especially with exponential functions, and then think about sign charts for behavior, more of an analysis in order to figure out whether there's actually an absolute max or not. But I think if you guys look at the analysis, you have a horizontal asymptote one way, horizontal asymptote another way, and then you have this max, and it's like, oh, of course, that's going to have to be. So anyway, we didn't actually talk about considering horizontal asymptotes, but that could be very helpful also as we go. Did you guys get the whole critical point? Oh, stationary point. What does it mean by there are no critical points that are not stationary points? And, yeah, and its derivative equals. And remember, stationary points are the ones where the zero. So there are no critical points that are not zeros, aka there are no non-horizontal tangent lines. Yeah. But remember, exactly. Not DNE or infinite or just piecewise, but those are all DNE. Good. X can equal. So your critical point was 0. Why are plus and minus 1s technically not critical points? It's not in the domain, but do we still put them in our sign chart or in our analysis? Yes, but they can't be maxes and mins because they're vertical asymptotes, aren't they? I don't. I put it in a domain and say x can equal plus minus 1 and then critical point at x equals 0, and I put it all in my sign chart. Because a critical point theoretically is an actual point on the graph, not theoretically, actually, which vertical asymptotes are not. They went ahead and talked about the increasing, decreasing behavior, so that would have been coming from a sign chart. They figured out there's a local max at 0, -1. Why is it only a local max? I think you end up going to infinity with one of the vertical asymptotes, so it couldn't be an absolute max. Does that make sense? Oh. I think it should have, just looking at the analysis, I think you should have come in with a positive and gone out with a negative. Because you would have had your -1, +1, 0. Oh, as you plug in negatives, a negative times a negative is a positive, but as you plug in positives, a positive times a negative is a negative. Because he's always positive down there. Yeah. 34, were you guys just graphing it and looking at it? Is it a piecewise function? Let's come back to that one. They just looked at it. No. Cheaters. We're just doing a candidates test for this one for absolute extrema. I think absolute extrema. They just did a candidates test of the critical points, but there weren't any endpoints. Simplify this, like into this, from that? Okay. No, it is a nasty simplifying one. I totally agree with that. I would have gone, remember they do the magical jumps. I would have done, I would have started here. I think I would have started there, and then I would have gotten a common denominator. Because if you're trying to think critical points, remember we want it all together, one top, one bottom. So I would have done a common denominator, because then actually this is quite nice. That's just x to the 1. So that's 6x squared plus 2x squared minus 8 all over 3 cubed root of x. Then it's a lot easier. Yeah, I would have done common denominators just with that little negative guy. I'm like, it's a fraction. Need to get it all together. There we go. And then 50 is b. Is that our last even? Yeah. I'm going to go steal, what was that, 34, the nasty one? 31 and 34? Oh, yeah, because he's a piecewise, too. Okay, 31 and 34 are super similar. Let me go over 34, just because it's an even, so you guys have any possibility of, and we'll see if it answers the 31 questions also, right? Extreme values. Domain is all real numbers. No endpoints, so we don't consider endpoints. You guys have to find k prime with, how do you take the absolute value of u derivative again? Yeah. And u prime is just 1. Absolute value of u all over u times u prime is just 1. Do I have one top, one bottom? Could I get one top, one bottom? I don't know about you guys. I think I'd much rather him as a piecewise. I think, I mean, looking at this guy, I think I'd much rather make it a piecewise. So here's how I'm going to make it a piecewise. Ready? I'm going to go from x, what do we have as our zeros? -1, and then 3. I'm going to go x less than -1, x between -1 and 3. I guess I could do an equal to. And then x. I tend to put the equal to's on the positive side. I don't know, just because I like it. It doesn't really matter because absolute value of 0 stays the same as opposite. Doesn't really matter. This one, you have to think about what's going on. If you plug in numbers lower than -1, is their sign getting flipped or staying the same? That's what you have to ask yourself. Opposite or same? Because it's either keep it and take out the absolute values, keep it the same, or opposite. So -2 plus 1, isn't it getting flipped? So that would be -x plus 1. -2 minus 3, isn't that getting flipped? Okay, so then minus x minus 3. There's that one. The next piece, oh, that's not going to work, is it? Oh, I can't undo. Okay. Greater than -1, it's not going to flip, so it stays the same. So x plus 1. Less than 3, though, that's still going to flip. And then greater than 3, not going to flip, not going to flip. So then I can go ahead and say, okay, this leads me to -x minus x is -2x minus 1 plus 3, plus 2 for x less than -1. X minus x cancels. 1 plus 3 is 4. Hopefully someone's double checking my math, because I'm not super confident. 2x minus 2. I'm fairly confident, it's just this first one. Negative 2x minus 1 plus 3. Huh. I like him better. Don't you?
We do like a mini lesson in how to turn like absolute values into piecewise functions.
That's not a bad idea. It's not a bad idea. Well, it's so much easier to visualize. And we're so used to piecewise functions because of the AP guys anyway. But then, hold on, this is still just k, though. Do we know what to do with it? We're supposed to be deriving it, right? We should also probably be thinking about continuity a little bit, too. But 4 equals 4 is fine, and then 4 equals 4 is fine. Whew, all right, at least it all matches up. You guys know what I did, right? Plug in, and then plug in, plug in. Everything matched. So then k prime. I don't know. Let's get rid of that. Sorry, when it gets down low, then I'm like, ugh. Negative 2, 0, 2 are my derivatives. Why am I not going to do any or equal to's? Because they don't match up. Sharp points. I have sharp points, which makes sense, kind of like linear, and then like, oh. But this is obviously sharp because not agreeing from either side of the values of the separators. All that to say, what's my only critical number? 0. And what's my behavior? Yeah, you're right. I'm decreasing at a constant rate. I'm flat for a constant rate, and I'm increasing at a constant rate, and I'm going to infinity. I do believe. But technically, the minimum value is, what's the minimum value? 4, right? The minimum value is 4, and it's for every value in between negative 1 and 3. So it's not just negative 1, and it's not just 3, it's all the values. Yeah, I would do interval notation, close bracket, negative 1 to 3, for all x within negative 1 to 3. We have the answer key. Why am I being so dumb? Let's go look at 34. Nope, that's not it. Hey, look, it's an interval. No, but maybe we'll talk about absolute value a little more before the test. Justin, it's a great idea, just not today, but it's a great idea. Remind me as the test gets close. And not that it's really specific to this section. Well, yeah, you're dealing with absolute values whenever they come, and this section's putting it all together. You guys had a question on 31, but I think, Aryan, is it okay if we try it tonight maybe and see if we can get it? Okay. I would change it to a piecewise, and I would have my separators be negative 3 and 2. Except you would end it. You have endpoints. So watch out for those. I mean, we have a derivative. It would just be setting the numerator equal to 0, but then you'd have to get common denominators and put them together. I mean, you know negative 1 and 3 are candidates. You're just not going to see the interval for everything in between negative 1 to 3, I don't think, without making it piecewise. Because you're going to have x minus 3 times absolute value and x plus 1 times absolute value. Like, basically, the absolute value shortcut notation breaks down and isn't really practical at this point. Does that make sense? Well, or we talk about absolute value more tomorrow so that you guys can make your own. Isa, 39, and then Maggie, 37, and then Aryan. 39, it was 39. About 31 or 34?
The one you just had.
Yes.
Wait, so I don't know why couldn't you, because like if you were to just plug in, like if you get the negative 1 and 3 are your candidates, couldn't you just plug in like a sign chart? Or go with it?
Well, how do you know there aren't any other zeros? See what I mean? So like in this problem, yeah, it was enough to look at the denominators, but the problem is, what if you had one in the numerator? Okay. Okay. Look at that. And Issa was so disappointed. And guess what? It just signed me out because of whatever the projector's doing. Go team. But you guys wanted 39, and I think, actually, you know what? We can just do 39 in the notes. We got this. Go team. We are problem solvers, right? Was that a question? Anyway. Yes, we are. Number 39. Maggie, was that yours too? You and Issa both? Cool. What's the function, kids?
It's piecewise y equals 4, and it's 2x, and x is less than or equal to 1. So the next one is x plus 1, and then
We're trying to do just extrema.
looking for find critical numbers and local extrema. And then
Okay. Right now, I don't see any possibility that this is 0. Because taking the derivative, I have slopes of -2 and slopes of 1. So I don't have any stationary points, right? But stationary points aren't the only kind of critical numbers. What are the other ones besides the zeros? DNEs. And why am I going to go ahead and say, hey, what's going on below 1 and above 1? Of the original function. What am I testing if I'm looking at the original function? Continuity. Well, either way, I should probably just have 1 be a critical point. But 2 and 2. Oh, they do equal. It is continuous. Why is that important? Yeah. So I can take the derivative, but what happens when I do take the derivative? Derivatives are limits. Limits have to agree from both sides.
oh yeah,
Therefore, the derivative does not exist. It doesn't exist because they don't agree. But couldn't you guys also technically, sometimes you forget what you can do. Couldn't you have figured out this as a sharp point by graphing 2 lines and having them come together? But we needed to know it was continuous first of all. Well, and I guess we did know that it existed at 1 anyway. But the derivative does not exist at x equals 1, so therefore there's a critical point. Not a stationary point, but there is a critical point at x equals 1, which means we need to think about domain was all real numbers, right? I don't think this analysis should take a lot of time because we just talked about how it's a downwards to an upwards. But if you want, we can go ahead and say, hey, it's negative then positive. What's going on at 1? Yeah. And technically, it's not even just local, is it? Why is it absolute? Strictly decreasing to strictly increasing, it's the lowest value possible. Sharp point. Okay, with that, maybe we'll talk about number 31 tomorrow. You guys maybe try to analyze it, see if you can make a piecewise function out of it tonight. That'll be fun. And we can talk about it a little bit. It's not what I want, but for right now, I'm already in notes, aren't I? Mean value theorem. M and a V and a T. Go team. I know, I'm going fast, but I think it's because you can handle MVT tonight. We got a little behind last week, but it gave you extra time on the extrema homework, and at the end of the day, I think you guys appreciated that. Am I wrong? Okay. I figured extra time on the extrema homework is worth it. What am I passing out to you? Well, you should get your test back tomorrow, I think. I hope. I'm aiming to. If I wanted to give you a chance to reflect first. Wait, what was last chapter? What was the test on? More derivatives. Well, but I could have had it graded but not giving it back to you today, but no. I was working on Google Classroom last night. And I was gone, I think, the majority of the rest of the weekend. Don't worry, I chose a very easy Sudoku. Mean. Like the ornery pumpkin farmer. No one remembers it from last year? The gourds? Aww. The whole story about the ornery pumpkin farmer and the cop had to use MBT in order to be able to pull him over? To be waving as he walked? No? James remembers. Maybe we'll see it again, because obviously it didn't leave an impression. Anyway, mean. What is it? Mathematically speaking. Before I finish writing it. Okay, never mind. Average. Mean, median, and mode. Median is the middle number. Mode is the most repeated number. Mean is the average. Add them all up, divide by. In stats, it's way harder, but that's okay. We'll pretend. Average. Average what? Average. What's the formula for average rate? Thank you. F of B minus F of A all over B minus A. Man, I really fried you guys with the absolute value piecewise. Man, did not expect that. Okay. Value. Value. I know. Yeah, this could be seen as a slope between 2 points, slope of the secant line. That's true. Average rate. Maybe let's go look at the theorem and then make our way back. Because the theorem says if f is continuous on a closed interval, differentiable on the open interval, there exists a number c such that But what value? What's equaling the mean? Careful, c is not equaling the mean. The c is the at, right? Yeah. We could say the value of the derivative at. Remember, c is our x value. C is our x value. But the long story short, the mean value theorem is the average rate equals the instantaneous rate at a particular x equals c within a to b, right? So average rate equals instantaneous rate. At x equals c. So is it enough just to find the average rate? No. We have to find the c where it actually occurs. But remember, the c has to be between the open interval. Last year we called them existence theorems. Just reminding you of that down below. MVT, it was a forever card. Wait, what's the special case of MVT? Why aren't we talking about that? Last year we started with that. Rolls. Rolls say. It's a guy's name. He figured out the specific application, then it was generalized later to be mean. Why am I holding my hands awkwardly up in the air, flat? If f of A equals f of B, if the endpoint equals the other endpoint, there must be a place where what equals 0? Where f prime of c equals 0 in between. But only for a continuous function on a closed interval, right? And differentiable on the open interval. Why does it have to be differentiable? Well, if it's differentiable, continuous, that's true. But also differentiable, doesn't that mean only smooth turns? Why is that important? If it was a sharp turn, am I guaranteed all the different values between the slopes of there to there that will occur? Or am I just guaranteed one slope, two slopes? Right? Sharp points are going to throw it all off. But smooth turns, I'll be just fine. Because smooth turns mean you gradually go into it and out of it. And it basically comes back to IVT. because you have a derivative that's positive, a derivative that's negative. You have to go in between all the different values. Anyway. Visualization only if it helps. It's in the forever card from last year, I think. Remember mean value theorem. You take the point A f of A, B f of B, find the slope between. The slope is going to be mimicked at least once somewhere in between because the tangent line is going to be parallel to the secant line at least one place as long as it's only smooth turns, aka continuous and differentiable. So, what do we do? They fail? What? I thought we were doing MVT. Why do they fail? What's wrong with him? Isn't his domain all real numbers? Okay, so he's continuous. So what must be his problem? He's continuous for all real numbers. I'm just applying it to this. Is it a sharp point? How can I tell that it's not differentiable? Well, guys, how do we deal with differentiability? Maybe graph, but we're trying to not have to think about graphing. So maybe instead I should just take my, what happens when you take the derivative? The derivative won't exist at fails MVT. Because it's not differentiable at x equals 0, and 0 is in between -1 to 1. Do I even have to think about like analyzing and explaining how it's a sharp point? Or no, it doesn't matter. Technically, it's a 0 over 0, so it's going to be a sharp point. But all I have to say is it's not differentiable. Derivative doesn't exist at 0. Some of you would have wanted to like cancel and reduce. Cancel doesn't make sense, but reduce. There's still a hole of the derivative. What's wrong with this guy? Why is it not continuous? But I totally agree. Good. You guys see it? You can say limits don't agree. Because coming from below, it would be 4, right? Coming from above, it would be 2. But wait a minute. Oh, maybe it does pass. Because look, that's an endpoint. That's good, right? But double check your theorem. Continuous on the closed interval, differentiable on the open interval. So MVT does fail once again. But if it was not differentiable at 1, would that be a problem? If it was continuous, no, it'd be fine. I don't care about the differentiabilities at the endpoints. I only care about the differentiability, the smooth turnness going on inside. That's why differentiability is, wrong direction, lo siento. Differentiability is on the inside. Continuity is on the endpoints. Oh no, we didn't finish. Antiderivative. Oh man. Well, an antiderivative just showed up. Guys, what's an antiderivative? Going backwards. See what you can do on homework. Go up until you think is reasonable to stop, take a picture, submit it. I'll give you full credit. Sound good? PS. Yeah. But they're not going to say integral yet. They're just saying go backwards. I forget why it's introduced in this section. Really weird timing as far as normal textbooks go, but you know our textbook, it's special. Bye, guys.